All right, so as we take a look here at number 34, almost identical to number 33, just some things have been changed around, but we're still simplifying by first writing the radicals with the same index and then multiplying. So we've been given the cube root of v, as in Victor, and are asked to multiply that by the square root of v, as in Victor. Well, we know that we can't multiply these two radicals straight away because we have different roots, don't we? We have a cube root here and a square root here, so we can't multiply the radicals straight away. So let's go ahead and first rewrite each of these radicals in exponential form. And that'll be v to the 1/3 here times v to the 1/2 here. And so here are the rational exponents that we're working with, 1/3 and 1/2. And again, we want to go ahead and take these rational exponents and try to come up with a common denominator. Rewrite each of these rational exponents with the same denominator, because once we have the same denominator, when we go back to radical form, the denominator becomes the root, and we're looking for each of these radicals to have the same root. And once our radicals have the same root, we can then multiply the radicals together. All right, so we have a 1/3 and a 1/2 here. What's our common denominator going to be? I think it's going to be 6 again, right? Just like 33. So what do we have to do to this 3 to get it to a 6? We have to multiply it by 2. And whatever we do to the bottom, we also have to do to the top. And here we have a 2. In order to get this 2 to be a 6, we have to multiply it by 3. And whatever we do to the bottom, we also have to do to the top, don't we? And so now let's go ahead and rewrite these rational exponents, having performed the multiplication there in orange. So we have 2 times 1, which gives us 2. 2 times 3 gives us 6. And here on the right, we have 1 times 3 gives us 3. 2 times 3 gives us 6. And so we have 2/6, 3/6. And we can see that those are equivalent fractions to the original rational exponents that we were working with. So here on the left, we have v to the, and now not 1/3, but now we're going to rewrite 1/3 as 2/6. And now times v to the no longer 1/2, but rather 3/6. All right. Now that we have a common denominator, let's go ahead and rewrite each of these terms in radical form. So this is going to now become the 6th root of v squared times now the 6th root of v cubed. All right, well, now that we have the same root, the same index, we can go ahead and multiply these things together. So we're going to have the 6th root of v squared times v cubed. And we know that when we multiply like bases, what do we do with our exponents? We add them, don't we? So here in this case, we're going to end up with the 6th root of v to the 5th. And that will be our final answer there. All right, so again, just like we did with number 33, we took our original radicals, rewrote them in exponential form, and in exponential form, you can clearly see the rational exponents. We took those original rational exponents, we got ourselves a common denominator, then rewrote each of those terms into radical form. Once they were in radical form, we could clearly see that the roots were the same, which means we can multiply these two radicals together. And it was just a simple process from there of using what we learned a couple chapters ago with multiplying like bases and adding those exponents together to arrive at the 6th root of v to the 5th. All right, let's take a look at number 35. I'll see you there.